Hello guys, welcome to OKONKOW Academy. This is lecture 2 of our course in probability and statistics, and we are still on set theory. In the previous video, I said I was going to solve a question in the next lecture, but I want us to continue with a bit of the set notations before we move on to the question. If you are new to this channel, I recommend that you please subscribe for us and put us on post notification, and also continue sharing our videos. Thank you. So for the set notations, we are going to define B intersection C prime. So we want to know which region is B intersection C prime, right? So region B, we have to define what region B is. Region B has, so I'm going to circle region B. So this is region B. And it has region 2, region 1, region 3, and region 6. So take note of that. So what is region C prime? I've always said that prime is just the elements that are in the sample space that are not in C, right? So C prime is regions that are in the sample space that are not in C. So first, let's circle C. Let's circle C. So this is C. So now we know what C is. C is regions 4, 1, 3, and 5, right? So any region that is not in C is in C prime, right? So for C prime, we have regions 7, 2, and 6. So regions 7, 2, and 6, right? So we are asked to find B intersection C prime, and so find regions that are common in B and C prime, right? So for that, we can see 2 is in B and also in C prime, and 6 is in B and also in C prime. And so the answer for this will be 2, 6, right? So use this same idea to find A prime intersection B prime and A prime union B prime. So what you do is that first you have to know what A is. Then you find the regions out of A. That will be regions in A prime. Then you do same for B prime. Then you find the similar regions in both A prime and B prime. That will be the answer. So tell me what it is, and in the comment section I'll make sure I check and mark it for you, and if I have to further explain anything, I would do a new video to explain it. Now let's move on to the main question. So this is the question, right? So this question has a combination of tree diagram and some notations as well, and set notations as well. So if you didn't understand the set notations when I did it initially, or the tree diagram when I did it initially, you can use this opportunity to regain that knowledge or understand it better. So let's move on to this. The question is, an engineering firm is hired to determine if certain waterways in Virginia are safe for fishing. Samples are taken from 3 rivers. So we have 3 rivers, and samples are taken from it. List the elements of a sample space using the letters F for safe to fish and N for not safe to fish. So let's say we have rivers 1, 2, 3. Let's name it River and Cobra, River and Cobra, River Okonkwo, I don't care. River, sorry, River Takrady. I'm naming my own rivers. So let's say this experiment was done in each river. So let's say they started from River and Cobra. So for River and Cobra, there can be 2 findings. Either the waterways is what safe for fishing, which is F, or not safe for fishing, which is N. And if river and cobra was safe for fishing, then the next river can be either safe for fishing or not safe for fishing as well. And if river and cobra was not safe for fishing, river Okonkwo could be either safe for fishing or not safe for fishing. And if river Okonkwo was safe for fishing when river and cobra was safe for fishing, then river Takrady could be safe for fishing or not safe for fishing. I hope you are getting the trend. And if river and cobra was safe for fishing and river Okonkwo was not safe for fishing, then river Takrady could be safe for fishing or not safe for fishing. Right? Then if river and cobra was not safe for fishing and river Okonkwo was safe for fishing, then river Takrady can be either safe for fishing or not safe for fishing. Then if river and cobra was not safe for fishing and river Okonkwo was not safe for fishing, then river Takrady could be either safe for fishing or not safe for fishing. Right? So you use this tree diagram to determine the sample space. So let me name that O for OKONKOW. So the sample space can be either safe for fishing in river cobra, safe for fishing in OKONKOW, or safe for fishing in Takrady. So F, F, F. Or safe for fishing in cobra, safe for fishing in OKONKOW, not safe for fishing in Takrady. Or safe for fishing in cobra, not safe for fishing in OKONKOW, safe for fishing in Takrady. Or safe for fishing in cobra, not safe for fishing in OKONKOW, then not safe for fishing in Takrady. Then we move on to not safe for fishing in cobra. So it can be not safe for fishing in cobra, safe for fishing in OKONKOW, safe for fishing in Takrady. Or not safe for fishing in cobra, right? So not safe for fishing in cobra, safe for fishing in OKONKOW, not safe for fishing in Takrady. So not safe for fishing in cobra, safe for fishing in OKONKOW, not safe for fishing in Takrady. Then we move on to here. Not safe for fishing in cobra, not safe for fishing in OKONKOW, right? Then safe for fishing in Takrady. Then we can go on to not safe for fishing in cobra, not safe for fishing in OKONKOW, then not safe for fishing in Takrady. So how many sample points? 1, 2, 3, 4, 5, 6, 7, 8. Right? And that is true because we have two outcomes. So the outcomes divided by to the power the number of the outcomes divided by the number of elements that we are using. So we are having 3 rivers and the number of outcomes could be either safe for fishing or not safe for fishing. So divide to the power 3 and that will give 8 sample points. So when we count we get 8. So this is a short trick. So outcomes to the power, right? Outcomes to the power number of elements or number of samples that are taken from maybe the thing that we want. So let's say in this case the rivers. So outcomes to the power the rivers, the number of rivers or the number of objects that we are doing the experiment on will give us the total sample space that we want. So the outcome that we wanted was 2, right? It is either safe for fishing or not safe for fishing. So to the power, how many elements are we performing the experiment on? 3 rivers in this case. So 2 to the power 3, which is 8. So we have our sample space as 8. I hope you all understand to this point. So now we've gotten our sample points, right? Or our sample space. The next question is telling us list the element of S, which is the sample space. So they want me to name the sample space S. So list the element of S. to event E that at least 2 of the rivers are safe for fishing. So this is an event, as I explained previously. Event specifies some conditions that we should rewrite the sample space. So they specify the conditions. So you take that conditions to rewrite a new sample space, and that will be the event. I'm using sample space because I don't have any word to use. So it's like we have the main body, right? And they're giving us condition to write something from the main body, and that is classified as the event. Yes. So let me go down. So now they said the event list the event of S corresponding to list the element of S corresponding to the event E that at least 2 of the rivers are safe for drinking, right? So we should get 2 rivers safe for drinking. So we can write this. We can write this because this has safe for drinking for river and Okonkwo, safe for drinking for Okonkwo, but not safe for drinking. We want just 2 to be safe. So this these 2 will count. Then I think that's it. So we are going to get event E to be F F N F N F N F F. So this is event E, right? Then let's move on to the next question. The next question was define an event that has as its elements the point FFF, NFF, FFN, then NFN, right? So they've given us the events now, and they are telling us we should define the condition that they use to write this event. That's the logic behind this. You see, for the question B, they gave us the logic that we need to write the event. They told us that at least 2 of the rivers should be safe for drinking. But now they've given us some events and they want us to describe what the event